Welcome all of you to ANIMATS. Today we are going to take up trigonometric identities once again. We had done one video in trigonometric identities. This is going to be my second video in trigonometric identities. In the first video we had taken up very elementary questions. It was an introductory one to identities. Today we shall be taking up the tough questions. So this video will have all the tough questions, probable tough questions of this chapter. These are very important questions. They have they are very likely to come in your exams. So see to it that you watch the full video. Every sum is going to be a different type. There is no repeat. So please see to it that you are watching the full video. Okay. So let us now start with it. So our first question is going to be, prove that, as I said, this chapter is only, all the sums are proving type. So 1 plus sine theta and 1 minus sine theta, this is equal to sec theta plus tan theta. So you have to prove this is equal to this. Now since this is the more complex side, we are going to start with this and we are going to slowly move towards this end. Okay, so LHS, left hand side. Okay, now what do we write here? Here we are going to take up, first thing is split this root sign and give it to the numerator and the denominator separately. 1 plus sine theta and root over 1 minus sine theta. Now if this is a minus, okay, if this is a minus, we are going to take a plus over here, that is into 1 plus sine theta, but inside the root sign. Here if we in the denominator, now a sum, how to decide what to take? Should I take plus? Should I take minus? That decision is to be made by seeing the denominator, not the numerator. So see the denominator, take the opposite sign here, and here if you have root, here also you need a root. Okay, now if in a fraction I suddenly cannot divide the denominator with a number, okay, in that case I have to keep the fraction same, I have to multiply the numerator also with the same number. Now I have multiplied with the same number, but how did I decide what to take? By seeing this. If this is minus, I take plus, not by seeing this. Okay, now I shall be, this is root x into root x is always an x, right? Because x to the power half into x to the power half is x to the power half plus half, which is x. Root x can be written as x to the power half also. So here I can just remove the root sign and write what is inside it, just for this reason. Okay, as you see it here. Here what do? I don't have same, the numbers are not same, the expressions are not same. So I can do 1 minus sine theta with a 1 plus sine theta can give me 1 minus sine square theta. This is coming from identities, algebraic identities. A plus b with a minus b is a square minus b square. So here 1 actually means 1 square. Okay, so 1 plus sine theta, and then this is cos square, but cos square is inside the root. Okay, so since cos square is inside the root, I can do this sine theta and cos theta. But then I can clearly see I still haven't reached my right hand side. So what can I do now? 1 by, for this I can write 1 by cos theta plus sine theta by cos theta. That is, I have given the denominator to both of them. Okay, in that case the first part becomes equal to, okay, the first part is equal to sec theta and the next part is equal to tan theta. That is equal to my right hand side. Okay, so it is proved. So this is one typical question of this chapter, where you will have the root sign and you'll have to use another root sign to take this out of the root. Okay, So let's take up another sum. This time also it will have a root sign. Let us see what it is. Note here. Here the question says 1 plus root over. Okay. The question says root over, it is 1 plus cos theta, and then root over, then comes 1 minus cos theta. Okay, and then a plus sign, and then again root over, here also root over. Then what do I write? 1 minus cos theta. So see, there is an alternate sign here, and 1 plus cos theta, and you have to prove this is equal to 2 cosec theta. You can write it here, 2 cosec theta. Okay, so this is what we have to prove. Now what to do? LHS, left hand side. Now since these here both of them have something in the root, in the denominator, product of them will be taken as the LCM. So this is my LCM, 1 minus cos theta and 1 plus cos theta. This product of these two becomes my LCM. Here I have 1 minus cos theta in the denominator. So what is not there, that is this, gets multiplied here. Okay, so it is root over 1 plus cos theta and a square, plus this is root over 1 minus cos theta and a square. Okay, so this is 1 minus cos theta here, and this is 1 minus cos theta. This is below this, it was 1 plus cos theta. So what is not in the denominator here, that is this, gets multiplied here. Okay, so now we'll have to see when I square a root, okay, it just comes out of the root sign like this. Root x square is only x, plus this is root 1 minus cos theta square is only, okay, so it comes out of the root sign. And then below I have, this is 1 minus cos square theta. Now if you note here, this will cancel, then I'll have a 2, okay, and then this is root, this is sine square theta. Yes, now 2 sine square theta with a root gives us only sine theta, right? This is equal to 2 cosec theta, which is equal to my right hand side. Okay, hence proved. Now let's take up another question of this chapter. This question, according to me, is the toughest question of this chapter that I am going to write now. Okay, so watch this question and try to remember this question. And this question, in order to do it in the exam, you need to do quite a few times. Only then you can do it in the exam. Sec theta plus tan theta minus 1, okay, and then tan theta minus sec theta plus 1, okay, is equal to cos theta and then 1 minus sine theta, cos theta and 1 minus sine theta. So now how do we prove this? You have to prove this side is equal to this. We'll start from this side, the bigger side, LHS, left hand side, okay, and then we start, this is here sec theta plus tan theta. Now some things we just need to copy, this much we'll just copy, denominator also we will just copy, okay, we'll just copy. Okay, what we do here is minus 1, here we are going to write sec square theta minus tan square theta, because what is this coming from? Okay, what is it coming from? This is coming from 1 plus tan square theta is equal to sec square theta. It is coming from this. So 1 is equal to sec square theta minus tan square theta. Okay, so here there was a 1. I have substituted that 1 here. In place of the 1, okay, so 1 is equal to sec square theta minus tan square theta. So I have written it in place of the 1. Okay, now I'll again copy the denominator. I shall not be touching the denominator. Here sec theta plus tan theta and minus sec theta minus tan theta, and this is sec theta plus tan theta. Yeah, and then tan theta minus sec theta plus 1. Yeah. So now what will we do? So here sec theta plus tan theta, this is factorization now. This one and this one is common from the two parts. I take it out. The rest, nothing can be taken from here. This is plain factorization. Minus this is left sec theta plus tan theta. This is a factorization that we have done very cleverly. And this is tan theta minus sec theta plus 1. If you see this and you see this, you note minus sec theta plus 1 plus 1, tan theta tan theta. So always put a bracket before you cancel, because if you are cancelling without the bracket, it will look as if you have cut only the sec theta. When you put a bracket and you cut, then it looks like you have cut the full bracket. So you want to cut the full bracket, put full expression, put a bracket and then cut. This and this, it is out. Now we are left with this much. Okay, sec theta plus tan theta. Okay, now this is definitely not my RHS. This is definitely not my RHS. Okay, so I will stop here. I can't say this is equal to RHS. As you can see, my RHS is something different. Okay, so what to do? What I will do is, I will convert this to this. So if I can say that A is equal to B, and then if I can say C is also equal to B, right, then can I not say A is equal to C? Okay, I am using this method now. So A is equal to B, C is also equal to B, okay, then I will say A is equal to C. So I shall be doing it in 2 steps. So my second step will be where I take this up and I try and bring this to this form. Okay, then I can say yes, hence proved. Okay, because the two LHS and RHS is equal. So I have here sec theta plus tan theta. You should remember it, because I am going to erase it now and I shall be working on the right hand side. So it's a very common kind of this kind of change, 1 minus sine theta here. Okay, now if you have a 1 minus sine theta, here write the cos theta, here 1 minus sine theta, and here, okay, this is my RHS, 1 plus sine theta and 1 plus sine theta. Yes, that gives me cos theta, 1 plus sine theta, yeah, and 1 minus sine square theta. Okay, so here whatever sign is there, I'll give its opposite. I've given its opposite, which is 1 plus sine theta, because I wanted to remove my denominator. If I have given 1 plus sine theta here, since it's a fraction, I need to give it up here also, because suddenly in a fraction I just can't divide the fraction with something. Okay, so this is cos theta by this is cos square theta. 1 minus sine square comes from the identity, this identity. Sine square theta plus cos square theta is equal to 1. Okay, from this if you see, 1 minus sine square is a cos square. Okay, and then 1 plus sine theta. Okay, if you have this, then this is 1 plus sine theta by cos theta. Yes, and that comes to 1 by cos theta plus sine by cos theta, which is equal to how much? That comes to sec theta, because 1 by cos is sec and sine by cos is tan. So I have reached where I had stopped with the LHS. Okay, so we proved the LHS and the RHS both are equal to sec theta plus tan theta, hence proved. Okay, so you can write, since we have proved both of them are equal to sec theta plus cos theta, hence we have proved the above proof. Okay, now let's come to another question. This is not such a big one, this one was huge. Okay, but then this one that I am going to do is small one, but then you will see a lot of tricks involved in it. Let's see. In this sum, there's a root over sign again, root over, okay, and in this root over sign, sec square theta plus cosec square theta. Okay, sec square theta plus cosec square theta and the root sign ends. This is equal to tan theta plus cot theta. Okay, so here I have a sec, then I have a cosec, and then I have a tan, and then I have a cot. We'll start from the LHS because the LHS is only looking more complicated. And here, this from our identity we take it as 1 plus tan square theta. Okay, and then here we take it as plus 1 plus cot square theta, that is equal to tan square theta plus cot square theta plus 2. Okay, that gives me, this is tan square theta plus 1 by tan square theta. Remember, this is cot is 1 by tan plus 2 into, I think I can write, if I write this, tan theta into 1 by tan theta. Now what is it? What am I trying to do? A square plus b square plus 2ab. So I have reached my algebraic identity a plus b whole square. Now there was nothing with the 2. There wasn't anything with the 2. But if I put something which cancels each other and gives a 1, I can put it here. Okay, so I chose tan theta and 1 by tan theta because I have that as my a and as my b. Okay, so I am trying to show you it is a square plus b square plus 2ab. So what is my a square then? Tan theta. My b square is 1 by tan theta. Yes, and a square. Okay, so this is my, from this I get my a plus b whole square. So it is a square term inside a root sign. So if I take out the root sign, the square will also go. That is, root of x square is an x. So tan theta plus 1 by tan theta. I have taken it out of the root sign. Now that is equal to tan theta plus cot theta. This is equal to my right hand side. Okay, so I have used the identity. First thing, I use the identity of sec square theta is 1 plus tan square. Then I use the identity 1 plus cot square is cosec square. These are trigonometric identities. And after that, I use the algebraic identity, which is a plus b whole square is a square plus 2ab plus b square. So I used it and I reached my answer. So now let's take up one question. This is little different. And generally people find this question to be very tough. It's not that tough actually. If you see, x is equal to a sin theta plus b cos theta. Okay, and y is equal to a cos theta minus b sin theta. Okay, what you have to prove? Prove that x square plus y square is equal to a square plus b square. We have to prove this. Now this is a very simple thing. The moment we see this, without thinking of what is going to happen, we are going to square this. Okay, you need not calculate it orally, or you need not think how will I get my a square plus b square. We'll just square these two to get x square plus y square. So x square is a square. I am using a plus b whole square for this. Okay, so you can do a sin theta plus b cos theta whole square, which is a square sin square theta plus b square cos square theta plus 2ab sin theta cos theta. Okay, so I have written my a plus b whole square identity here. Now next is y square is a cos theta minus b sin theta and a whole square, which is a square cos square theta plus b square sin square theta minus 2ab cos theta sin theta. Okay. Now if you see these two things, if I add these two, okay, here I'll add x square plus y square, and I'm adding the two equations. So I add the left hand side, and then if I add the right hand side, a square I'm taking common, sin square theta plus cos square theta. That is, I added these two terms right now, this and this. And then b square cos square theta plus sin square theta. Okay, that means I added this one and this one now. Okay, so I took b square. In one step only I have done. I have taken the b square common. Okay, this one, the last two terms are exactly same, so I am going to cancel them out. Okay, here this is one of the trigonometric identities, which is 1 plus b square. This is again 1, x square plus y square. So you see, just with one square and using the algebraic identity a square plus b square, I have reached my right hand side, hence proved. Okay, so I have proved it. So this was one type of question. We are going to take up another question almost like this, very much like it. Okay, now what is that question? Let's see. Here the question says tan theta plus sin theta is equal to 1m. Okay, tan theta minus sin theta is equal to n. Now we have to prove that yeah, m square minus n square is 4mn. You have to prove this. Okay, how do we prove it? So now here, first thing is I am seeing this and I am seeing this. So when I note it, I just do m square, which is tan square theta plus sin square theta plus 2 tan theta sin theta. That is just my a plus b whole square identity. Then n square, which is again tan square theta plus sin square theta minus 2 tan theta and sin theta. Okay, so I have done it. Now what next is, I'll have to subtract them, because they have told here subtract. So m square minus n square, if I subtract, this is gone, this is gone. Yeah, these two are gone. Here this, if I subtract, it becomes a plus. So it becomes 4 tan theta sin theta. But then I haven't reached my answer. Okay, so I will have to prove this one. If I can prove this is equal to root of mn, then I can prove it. Then it is done. So at the moment I am going to stop here. Okay, and I am going to start working on mn, because I am seeing here mn. So m into n, let's see what happens. Tan theta plus, so this is the second part of the question starting. Till now I reached here, I stopped. Looking at this, I am trying to get my mn now. Tan theta plus sin theta into tan theta minus sin theta. Now I am going to multiply. This is clearly a plus b with a minus b. which is tan square theta minus sin square theta, and that gives me, okay, tan square theta minus sin square theta. So I can write it as sin square theta by cos square theta. Okay, I can write it as a sin square theta by a cos square theta minus sin square theta. Now here I can take the sin square theta outside the bracket, 1 by cos square theta minus 1. Small factorization I have done by taking the sin square common. If I have taken the sin square common, this is sec square minus 1. Yeah, this is clearly sec square theta minus 1 because 1 by cos is sec. Okay, which is equal to sin square theta, and this is from my identity, trigonometric identity, this is tan square theta. So what have I proved? Mn is equal to sin square theta tan square theta. If I do now root mn, yeah, if I do root mn, that is going to be what? That is going to be root of this also, root of sin square theta tan square theta, that is equal to sin theta tan theta. Yeah, so root mn is sin theta tan theta. Now what can I do? Since this is root mn, yeah, I can substitute sin theta and tan theta over here. Okay, or here this is tan theta sin theta. So what I can do is now m square minus n square, I am copying this, is equal to 4, and this part, that is this part, is equal to root mn, hence proved. So I have proved the identity. Okay, so these were some of the tough questions of this chapter. So these were some of the tough questions of this chapter. We'll end the video here today, but then I shall be coming up with few more questions of all difficult questions in trigonometry, okay, identities and standard angles, and the first chapter in trigonometry very soon, where you'll have very tough questions according to your exam level coming up soon. Okay, so to revise the identities chapters and to practice the identities chapter, these sums from these two videos are good enough. So you can practice from this. If you have liked the video, do not forget to like, share and subscribe. Thanks all of you. Bye then.